Good afternoon, everyone. I welcome you all to ET Energy World webinar. To present this webinar, I welcome Mr. Anjani Agarwal, Partner and National Leader, Metals and Mining, EY, and Mr. Gangadhar Krishnamurthy, Director, Business Advisory Services, EY, on the topic, how new generation digital technologies can help boost metals and mining sectors. There will be a presentation on the topic, followed by a question and answer session, wherein you may submit text questions to today's presenters by typing your questions into the questions field of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the question and answer session at the end of the presentation. Now I request Mr. Anjani Agarwal to start the presentation. Over to you, sir.
Thanks. Ladies and gentlemen, welcome to the ETY webinar. Today we are discussing how new generation digital technologies can help metal and mining businesses sustain and grow successfully. Technology, as you know, is driving and enabling change and also transforming businesses and practically every business, both old generation and new age. It is not only changing the way business is run, but also opens up new avenues and opportunities for growth. Metals and mining sector is no exception. They may have been slow to start in somebody's opinion, but they are increasingly adopting digital technologies. So let's first set the context in which the global Indian environment provides to the sector. Currently, the metal sector is experiencing a hugely favorable global environment, as well as support by the initiatives of Government of India. Global economic growth, as we know, have been robust, particularly in developed markets and the Western markets. The emerging markets are doing their own bit in terms of growth. From an Indian context, the government policies have also been supportive of the domestic production, as we have seen in the case of the steel sector in India. If we look at the domestic economy, growing urbanization, housing for all, and the initiatives that we are looking at in both highways, railways, and power sector, they augur well and they really entail huge infrastructure investment. Hence, we believe construction will remain buoyant for several years to come. The auto sector has also been experiencing robust demand growth and is expected to stay strong for several years to come, riding on the income profile enhancement and economic growth in the country. So all in all these augur well for a sustained demand growth for metals and also for minerals for a very, very long term in the Indian context. Moving over, metal prices have strongly rebounded during 2016 and 2017, well supported by the demand as we discussed, and also at times due to supply constraints triggered by, for example, the China's steel capacity shutdown and also their environmental related initiatives to cap production, particularly during the winter for aluminum and steel. We have seen the graphs provide you a reflection of how the prices have improved significantly over the last couple of years. The steel prices have improved almost 40 to 60%. The base metal prices of aluminum, copper, and zinc, all of them have experienced price increases anywhere between 15 to 60%. From, of course, their absolute lows a couple of years back. Moving on, even the bulk mineral prices have rebounded early in 2017, but of course they have been little more volatile as always. The thermal coal prices have sustained over 50 to 60% of their earlier prices at $60. Even the iron ore prices have improved but have struggled of late, largely in the global market because of very large, very economic world-class capacities coming on stream, which are very, very low cost in Australia and Brazil. The Indian context, however, for the iron ore market has been fairly strong. It's another matter that we are experiencing capacity cuts and other physical constraints in the iron ore business. What all these have led to is a significant margin expansion in the metals and mining businesses, most of them. Healthy demand growth coupled with some protective measures, as we discussed in steel and aluminum, and some supply-demand balancing globally have contributed to producers' margins, and they have been robust. As you can see in the graph, globally for both steel and aluminum, the EBITDA margins have increased consistently and significantly, and also within the Indian context as well. Both these businesses in general have experienced a significant boost in the EBITDA margins. It's another matter that in the Indian context, much of these EBITDA go to service the debt and cost of financing. The margin trend is similar, as we said, globally as well as India, and there is all around, this augurs well for the industry, particularly the metals players, and there is all round optimism as we see in the business. Every domestic player that we know have either expanded or looking at significantly expanding their capacities. Amidst this optimism, there is a need for some reality check. Not all parts of the industry are doing well, and we see that playing out in the steel sector and some other sectors as well, and in some mining sectors as well. Some businesses are under significant stress, as we know, and have always been volatility. I mean, in this business, volatility is here to stay for long, and because of the cyclical nature of the business, we see a hugely volatile growth and margins. The trade policy measures, however, adopted by the Indian government have been benevolent, have been supportive. However, you cannot assume that to be either perennial or sustainable over a long term. While domestic demand and trade policies have helped, these cannot be relied as the only recipe for success. So what are the other challenges that remain that needs constant attention? And here are some that are relevant in the immediate and midterm. I'll deal with some of them in a little more detail. Global competition. Global steel capacity overhang still plays out despite 100+ million tons of capacity degrowth happening in China. China continues to persist its aluminum capacity expansion. On the mining side, increasing domestic taxes and logistics costs make the Indian mining sector less competitive, which then transitions to the metal sector as well. So in view of the global competition, the Indian metals and mining sector would have to address this on a consistent basis, as some of the trade policy support might play out, and we may see a sunset clause on that. Resource security. Despite India's huge geological potential, our exploration performance has significantly lagged behind the growth in the needs of minerals in the country. This needs to be accelerated by bringing in technology and expertise from overseas markets. That only will expand the resource base, which can provide a security of supply to the Indian minerals and metal industry. Productivity. In the commodity business, achieving lower cost of production is really the foremost strategy for success, and productivity in that context is the key. There are examples even in steel industry where we have seen some of the non-integrated players have used productivity as a tool and a lever to compete with the integrated players who have access to low-cost raw material. In the mining segment also, India does not have not many world-size economic low-cost assets that are amenable to huge productivity tools. Capital assets and access to capital and cost. We all know that due to the high cost of capital in the Indian economy, much of the EBITDA margins go to service the cost of capital, which is high, and hence also working capital management comes to the fore as an important focus area for the metals and mining industry. Speed and time. Speed of education has not been an area of strength for India in many ways. Our project commencement and execution delays do indeed push up the completed cost of the facility and capital investment for the given capacity to make it competitive, and it imparts a bit of non-competitiveness to the Indian industry compared to the global benchmark. Even for the government sector, the activities, the processes are so cumbersome and they take so much time that all these delays add to cost of completing our business setup. Operational excellence. Despite raw material security for many metals in the country, Indian producers struggle on account of operational efficiency, largely around your asset management, asset maintenance, and also quality. They have been continuously an area that needs improvement and attention by the Indian industry. The other transformational change happening in the sector is changing in products and solutions and markets. There's a lot happening out there. For example, lightweighting of vehicles, renewable energy initiatives, emission norms evolving, electric vehicles coming, low-cost housing as a need for the industry. All these are examples of what is transforming and triggering these changes. A product sale is giving way to solutioning more and more. These needs a different kind of organizational ability and capability for success for metals players. Agility and responsiveness. Due to all these reasons that we just discussed, there is an immense need for the business being agile and have an agile supply chain and cater to or address the demand forecasting needs, higher visibility and traceability into the supply chain, etc., etc. As the economy moves also, and every player is looking at significantly moving to value-added products, that itself also imparts its more complexities into the supply chain in optimizing sales and operations planning. Environment and safety. This is an area on which historical performance on these areas have not been something that we can boast of. Judiciary and other stakeholders have been pretty active on this. We are going to experience more stringent standards going forward, and the industry would have to respond. Sustainability performance will more and more come under spotlight for the Indian industry. Going forward, companies would need to be more mindful of this and required to be more responsible and be responsible throughout its supply chain and operations. Last one but not the least, governance compliances is an area of increasing focus and going forward, and also subject to immense scrutiny from all stakeholders. Now, as we have seen, as we can observe, all these challenges are not temporary or transient. They are here to stay for long, and hence need constant attention and regularly and consistently from the industry. While some of them may be external, most of them are internal to the organization and can be addressed by using several methods and tools that are available in modern economy. Most of them are around productivity, cost efficiency, operational improvement, safety, security, environment, governance, and responsiveness, and a networked economy. We believe that digital can be a key driver for success in these regards, and let's see how. With that, I hand over to my colleague Gangadhar.
Thank you, sir. So before I set out to explain how digital can enable the metal and mining industry, let me set the context, the perspective of how we have progressed in terms of manufacturing. So everybody is aware that 1700s we had the first industrial revolution, from where, from manual labor you were powered by steam and water. So you had the prime mover part of the whole manufacturing process, the production process, which was helping in improving your production or the quantity part of it. And you had done away with the manual labor, and you had you had steam and water to actually power your production processes. And then came electrical power, which was much more efficient than the steam in terms of the size of the machine, the control that it could do, and the speeds and the different variants the production process could take over. Well, from the 1800s to 1900s, we had the PLCs, the programmable logical controllers, the SCADA systems, where what we call as the basic digital system coming into and controlling these prime movers, be it pneumatic, be it electrical, or be it hydraulic. And we had these to actually control the sequence of the system in which a production machine would operate. And that's where we were in the earlier 1900s till possibly the 1970s. And today what we call as digital is something offshoot of what happened in the 1970s. And why so is basically because the technology is affordable, the size of memory has increased that is available to handle data. The size of equipments have gone smaller, and also they are connected in the sense that network technologies have improved. Plus, if you look at it, the skill that is available today with the younger generation is also more literate towards the digital era. So that's what is digital in terms of creating intelligence from the information that is actually stacked from the data during the production process. And this intelligence actually helps you to take decisions anywhere, anytime, and it is contextual. So that is what is digital, and it can be like any of the technologies that is being used, like the mobility, cloud to store, you could have sensors and all that, which I'll come onto later. But looking at it, the digital operation actually creates an environment for you as a virtual production system, which you can tap into and help your decision making with the data that is captured from your production system. So what does it give you? It gives you real-time information that is contextual for your decision making. It gives you advanced analytics that can be, that can process multiplicities of data and give you the right decisions that you need to take. It enables flexibility and adaptability in your production processes. It facilitates end-to-end, not only within the organization, but also across the supply chain, be it the supplier, logistics, or the customer. And it also enhances worker safety, because now you exactly know what he is doing, where he is doing, in which environment he is working in. So that's what digital is creating in the metal and mining industry today. So talking about digital transformation and the key technologies, I will just look at what is termed as digital in terms of the production environment. It is basically demand-driven production, which is agile and flexible manufacturing. And what does it have? It has solutions like smart assets. When we call smart assets, basically the machines or the equipments are talking either to each other or to the person who's in charge of maintenance or production. You have smart processes, wherein the process, be it a mining process, a blending process, or be it a smelting process in an aluminum industry, these processes basically generate data which is collected, and information bank is built on that to bring in intelligence as to how the process is behaving, what needs to be controlled, is there a variance, is there a deviation. So that's with the kind of solutions that the digital is bringing into this industry. Even sales and marketing is changing, and you end up today by analyzing how your customer behaviors are, how your customer demands are, what is required. And when we talk about customer, it's just not the end customer, but it could be your processes down the line. So those processes also, you will know what is the demand, how are they reacting to what the end customer requires, and how do you have a sustained customer relationship in terms of, if I take an example of steel industry supplies to the auto industry. So how the auto industry is changing, how the designs are changing, what is the repercussion on the steel industry, what needs to change in the steel industry so that the auto industries can become more innovative. So that's the relationship that is building in, and it's building in between the mining industry, metal industry to the the product or the consumer product industry. That's what it is. New products, research and developments have become easier because today you have modeling, analytics that actually gives you a virtual environment wherein you can test, play around with a virtual production system, and you would be able to fine-tune your systems according to the output that is actually coming out from the digital twin. Now, what is digital twin? Digital twin is exactly the replica on a virtual media wherein you are able to run a process or run a rolling mill in terms of a steel industry or run a smelting in terms of an aluminum industry and see how various parameters when changed would affect the process and the end product. And that actually helps you shorten the new process development, new product development, and optimizing the entire product life cycle. It affects your suppliers, it affects the entire supply chain, I would say. So you will have new ways of procurement, you have e-procurements, you have consolidations happening across the organization, you have fresh contracts that is coming in. So how the whole thing is monitored on a digital platform, on a virtual platform. And manufacturing, of course, has changed a lot, especially in the metal and mining. If you look at it, the small industries have now aggregated into bigger umbrellas. So the need for global planning, global scheduling has come in, the optimization has come in as to how do you want to produce so that you deliver at an optimum cost to the customer, making the right profit that is required. So whether you need to be near the market or near the raw material, and how do you plan it across, where to produce it, how to transport it, and that's exactly what's happening with global planning and optimization. And why is this happening? Basically because you have data available to you on one single integrated platform, which is what we call it as digital. So at the end of it, if you look at it, agile and flexible manufacturing is basically being driven by operational excellence in entire function of a business on which is driven by data that's collected at every instance of the business function, and that gets converted into your decision making. Now, looking at what are the digital technologies, I've listed a few. One is machine-to-machine communication. As to, like we said, smart assets, smart machines, they talk to each other, and when operating in a sequence, they send signals to each other as to what should the other perform with respect to this. Giving you a simple example as to in a steel industry, how a roller table motor would actually follow the main drives of the rolling mill. And that is today, if you look at it, 1970s, 80s, it was a wired technology with a lot of formulas getting in. Today it is wireless, and you can hook up a lot of information on the wireless. And there is a machine-to-machine communication that's happening. So the speed controls can happen there. Asset management can happen on machine-to-machine. Collision avoidance in mining industries can happen when you have machine-to-machine communication. The two dumpers on the same road talk to each other with keeping a safe distance and trying to avoid the collision. What has else changed is the way you actually collect the data and store the data. You don't have to have those big server rooms, the data centers, to actually collect and store the data which needs to be processed for your intelligence at the next level. Today, cloud platforms are available, which is exactly the virtual data centers that you can use, and these are fast, secure, as well as they can be connected from anywhere, and that has actually helped to access data, store them, and work out analytics on that to give you better intelligence. Talking about data, I think what you do with the data is what helps you to take decisions, and that's where the big data and the advanced analytics come in. And today technology can handle millions and zillions of data in one system to give you the right mix of decision that would suit your production environment, and that's where the big data comes in. What else has happened is basically you have an integrated production system, and when I say integrated production system, information flow is on the horizontal, right from the shop floor to the business function. A sensor would actually talk to a system, the system would talk to the planning engine would talk to the business functions in terms of cost, people, skills, etc. So that's the vertical integration that you have, and then you have horizontal integration in terms of, like, one process talking to the other process and sending out the process variable. So you have the entire process chain where each of these parameters which is going to affect the next process is passed on along with the product, and you have entire integration of the OT layer, which is operational technology, the shop floor technology, with the IT layer to take better decisions as well as to improve and optimize your operations. What mobility has brought in is basically giving you these intelligence and the contextual data on a platform which is with you on a virtual environment wherever you go. So basically you need not be at the control room, you need not be near the machine, but then this information is basically available to you wherever you are, and you could pass on your decisions, or you could control the machine from wherever you are, and that's what it brings in. And all this basically requires a robust network, and technology has actually helped in terms of creating networks of picking up data from the sensors, machines, systems, legacy systems, getting them connected, and giving you reliability of the data flow. What else has happened is the industry has adopted IoT, which is basically the sensors which can be retrofitted into your present processes. And these sensors, if you look at it, are basically 90% of them are non-intrusive, or at least they require minimal modifications of your processes or the equipment. So industry Internet of Things is what is bringing in the data that is actually required to analyze for your contextual intelligence, and that's what is making the machines and the processes smarter. So these are the few 7 or 8 technologies that is actually bringing in the digital transformation, giving you smart processes, the robust dynamic supply chain, agile and flexible manufacturing. Looking at a mining value chain, how a digital would actually enable it, it actually helps you in the various processes of mining, right? It will actually help you to know how you can improve a productivity, right, in terms of sensors mounted on the mine field, sensors mounted on the equipment, looking at how you can actually validate the plan from the geologist as to what he has expected out there, and that way you can bring in better productivity. You can shorten the life of, you can actually shorten the validation of data that will actually help you to simulate and bring out better recognition from the system. It also actually helps you to simulate the entire value chain of the pit to port, how the whole thing will operate in terms of your mine plan, your material movement, and it gives you the entire picture. And that is what your modeling can do, the simulations can do for you. It also can integrate with various systems that bring in variability in your operations, be it weather, price volatility, or any other incident that can happen, and this integration is possible with various systems on a digital platform. Asset management is one of the critical things in the mining and metal industry, and that's where digital adds a lot of value in terms of monitoring the overall equipment efficiency, in monitoring the availability of the machine, monitoring how much output each of those machines are giving, what are the process parameters that is getting monitored, what is the cost that goes into utilization of that particular assets. And also it helps you to tune your processes, production processes and the production schedules so that you can address the variability that comes in because of the customer demands or the customer requirements. This was on the operation side, but if you look at it, digital is also impacting the other support business functions like your HR, project management and finance. And how is it doing it? Any repetitive job that is basically structured and has got an SOP can be basically automated, what we call it as robotic process automation, and that improves your back office operations by reducing the time taken, say a purchase order creation or basically a leave application and a leave approval. So the effort and time required to do these repeated jobs are basically reduced. It also helps you monitor your projects much more closer. The drone technology tells you like what's happening on the field. You have sensors on the field that actually tells you meter by meter what's happening in my mining in my mine, and that actually reduces your time taken to complete a project or time taken or the capital cost that is invested into the project. And all this has a better control, so basically you have a better mechanism of monitoring the risks, and these risks actually drive the digital technologies to improve on the data that is getting collected, the intelligence, and that way you're able to mitigate those risks. Another contextual example that I'm giving here is from the steel industry as to basically how it can help improve efficiency and sustain your production system. It's an integrated steel plant that I've taken an example of. It can actually help you by monitoring the real-time processes, the quality in terms of what is going into the torpedo, location of the torpedo, how much time does it take from the iron making to the steel melting shop. Similarly, tracking a ladle, what goes into the ladle, what is the chemical composition. It gives you the entire genealogy of the process parameters and the product parameters, and it is like a finished coil is basically talking to you as to what its journey was, right from the blast furnace to the rolling mill or to the finishing section where it is getting strapped, packed and sent to the customer. And it takes its information to the customer also, so the customer can use this information for his own optimization of his operation. So basically what we look is basically how you can optimize under the circumstance of cost pressures and the speed at which you need to deliver. How do you collaborate across your supplier to your own manufacturing to the customer? How do you harness the power of data to bring in contextual intelligence and take decisions that can actually improve your yield, that can reduce your breakdowns? How can you upkeep your assets so that they are available for you more often than being broken down? So that's the context in terms of a steel industry, and all this is basically to address your demand-driven supply chain and customer satisfaction. But what needs to basically adopt to the digital agenda, and this is where we put in some thought and we said these are three things that needs to be done, is basically you need to understand how digital technologies is going to work along with the legacy system. I mean, doing away with the legacy systems is not the answer. You need to work along with the legacy system, and that's where the digital system actually help you, because they are non-intrusive or they can be integrated along with the legacy system. And you need to create a digital architecture along with your IT or the enterprise architecture that exists in your plant or in your organization. The second thing is, today we connect in digital, we recommend to connect all the equipments, the processes into your IT layer, or I would say the data, is exposed to a certain extent into the internet world. So how do you reduce the risk of being cyber attacked? So cybersecurity is one of the key aspects in designing your architecture as well as designing your IT operations as to how you would protect yourself from these cyber attacks. The third one is the people part of it. How do you reskill and skill the end users to adopt these digital technologies so that they make maximum use of the information as well as the technology platform in order to achieve the objectives that the digital is driving today. So with that, I think we talked about how the metal and mining industry is trending in India, what is digital and how digital is driving production, productivity, optimization and demand-driven supply chain in metal and mining industry. Thank you. We are open for questions now.
Yes, thank you. Now I request the attendees to send in their questions.
Yeah, the question is, what has been the experience of Coal India in adopting digital technologies for mining? Coal India has been one of the, I would say, amongst the Indian mining industries, one of the front runners on adopting digital. And I remember they have done, if I'm right, it is basically operator OITDS, the truck dispatch system, operatorless truck dispatch system, using RFID boom gates, which were all interlinked, and then connecting the weighing machines onto that. So yes, they have been front runners, but then of course there needs to be a lot to be done, a lot to be learned from what's happening globally, a lot to be learned from cross-pollination from the automotive industries.
The next question is on will the current emphasis on infrastructure creation and corresponding increased metal demand be satisfied domestically? I would say yes and no. I think we all know that demand is going to be robust for a long time to come in the Indian economy. So while the demand side is secure, I think the supply side response is something that we need to think about. And in some ways, while there is some raw material security available, particularly in terms of iron ore and bauxite, I think the other pieces of what it takes to set up a plant in terms of infrastructure, land, is something that an area of challenge historically, as we have seen in the country. I think the government is sensitive about it, and we believe that a concerted effort will happen. It will be sad to see that India will start importing much of its metal requirements. I think all stakeholders will put their heads together to meet the growing demand.
Yeah, the next question is, what is the level of digital penetration in Indian steel plants? It varies, but I think we are making attempts, and I would say it varies from almost I would say 10% to almost 50%. And I will not be right or wrong in saying that metal industry or mining industry has been digital, but then it has been digital in silos, it has been digital on the shop floor. But here what we mean by digital is actually interconnecting entire system on the internet, and using the power of cloud to be on the internet, to be mobile with decision making anytime, anywhere. So that's what it is. So some of the organizations have taken steps. Some of the organizations are looking at use cases that would give them immediate returns, like ladle tracking or torpedo tracking is something that they have. But yes, in the field of logistics, in terms of the packing lines, most of them have actually done some work on that. what the next question is, what will be the effect of labor and capital mix on going digital? To answer that, of course, like, for a country like India, I mean, where once ample labor was available at a reasonable cost, I think the scenario is changing. And if you look at it, even in the agricultural sector, the farmers are going digital in terms of, how they fund themselves, how they procure their seeds, and that's exactly what's happening in metal and mining. There's nobody without a mobile, and they will be actually happy if you look at it to punch their attendance through a mobile. So yes, so it looks like Indian labor is getting digital, and that is actually going to improve his working conditions, which is actually going to bring down, I would say, the capital cost when you actually go digital, because your productivity and the capacity utilization is actually going to increase.
I think it's a question of reskilling the workforce as well, and we know that several players in the country are taking initiatives to increase the digital awareness of their talent pool. And it has been hard. If you look at closely, it has been hard to attract top talent in the younger generation to this mining and metals industry. But that is something going to change. And I think that when the industry adopts some of these modern technologies, that will be another lever to attract back talent into the sector.
Sure. Which are the benchmark companies in terms of digitization in metal globally and in India? Tough question to answer, but yes, at different functions or different levels, we do have digitally managed production centers. Vedanta being one of them, Hindalco, yes, Tata Steel is yes. Of course, the public sectors are a bit slow to adopt, but then yes, I would say the private sectors are fast movers in this case. Siemens has signed a big deal with the Bao Steel of China for a digital steel plant. Are there similar deals in India? So I don't think there are deals in India, but globally, yes, we are looking at one of those smart steel plants, smart steel plants, which is basically, automating the process and control from a virtual environment. So yes, I mean, in India, I'm not aware, but globally, yes, it is happening.
I would say that I think it has been hard to sort of adopt digital technologies in a erstwhile plant, but whenever there are new expanses coming in, we do see a significant move towards adopting digital technologies in the new operations, and we have seen examples of that in both in steel and as well as base metal industries, even within India.
The other question is how to handle low literacy level of workers working at shop floor of steel industry and making them aware of digital technologies, especially at raw material locations. I mean, I can answer this question very simple, that people have transformed from SMSs to WhatsApp today, and this transition happened quite fast, and people have adopted to digital. It just becomes that the organization needs to become digital, the culture needs to become digital, people adopt to it. That's what has been our observation all through. These government policies.
There is a question: these government policies are aligned to expedite an implementation of digitization, mainly for existing setup? Well, I think there is enough and more business case for adopting digital as a tool and lever for doing several improvements, in terms of productivity, operational excellence, agile supply chain, health, safety, and environment and governance. So, if I guess the industry should not be waiting for support from the government. We would rather have the government to support strategic requirements around, as we've seen in the steel industry, for trade policy support. I think there is enough and more business case. So one of the policy advocacies we as a firm have been doing, particularly for the mining sector, is to can the government provide a window of opportunity on the lines of, let's say, the Textile Technology Development Fund to fund some of the initiatives around environment management systems and digital-led technologies to manage that, to de-risk really the growth for the sector and not necessarily to support individual enterprises. So yes, I think there are a lot of discussions happening, but there is a bit of way to go forward on that. But I would suspect that the industry should, on its, it's a good business case, and it's in terms of cost, quality, and growth enablement. There is enough and more to on its own, and it will pay off pretty soon than we expect.
The other question is, any global benchmark for implementing digital technologies in the copper industry? So I would like to share this thought that it is, there's no benchmark as such. If you look at it, the industry is adopting it to optimize its process, achieve its objectives at a optimum cost and making reasonable profit, or running a good business. So anything that is going to help you to achieve your objectives, your KPIs that you have put into your vision and vision statement is what is digital technology going to help you. So there are no benchmarks as such as to smelter optimization or logistic there. I would say that everybody is adopting, and that's why today we actually don't have a common reference for digital as well as Industry 4.0. It's evolving, and I think the industry players have to come down together to create that a common reference as well as the benchmark that is required.
But we do know that even the copper players, as the steel players and aluminum players have taken steps. They are. It's not. It's a journey. You cannot do everything in a day. You need to develop a roadmap as to what makes sense, what should be the phasing, what is the capacity to absorb new modern technologies. So it's a journey, and we are aware that almost every player in the country, a major player, I would say, are seeds of this initiative. And all of them are at some place in the journey for adopting these technologies. If it comes to steel sector, I can say that one of the latest steel plants in the world, Big River Steel, the readers, attendees may want to check their websites. They're talking about really a smart equipment, smart facilities, and they're talking about some 50,000 sensors, or if I'm not mistaken. And it's a thinking machine that they think, and as they progress, the equipments will take care of their own, have a brain of their own, and they'll be able to take care of their own in terms of productivity, efficiency, energy savings, etc., etc. So there is an example that the steel industry talks about, and one of them is Big River Steel of US.
The other question is, additive manufacturing or 3D printing is an emerging technology going to transform manufacturing industry. How do you see this affecting 3D printing industry? So it's a combination of new material and the 3D printing technology. So the metal and the mining industry is going to help in creating those new material that can actually enable 3D printing. But if you look at the adoption of 3D printing in metal and mining industry, it's right now being done at for making spare parts or the modules, which we call it, which goes into your equipments or the structurals that you are using, and it's an experimentation stage right now in metal and mining industry. But yes, there are researches going on in terms of new material, modularization of your equipment and the assets that can in future adopt 3D printing and reduce your inventory cost as well as the manufacturing cost. presently what % of these digital interventions are implemented during construction phase of project life cycle. If you look at the new mills or the new plants that are coming up, I would say they are almost 50 to 60% digitally ready. And when I say digitally ready, is they are designed to be integrated to generate the data, and I mean you have third-party applications that are actually going to use this data and help you optimize your operations, maximize your production and productivity. So yes, new plants are digitally ready to 50 to 60%. Old plants are being retrofitted, and that's where, like, it's not a project when we do a retrofit on the old plants, but it is basically use case based or very specific requirements where we adopt digital technology. With the adoption of digital technology in metal and mining industry, where do you think energy requirement move towards? Will we see a shortage, or will efficiency gain will reduce energy consumption significantly? A good question. So we are actually moving from energy monitoring to energy management, and that is getting digitally enabled. So basically what is happening is your energy per ton of, say, steel or metal that you're producing is monitored so closely, plus your process is monitored so closely that your energy demands are part of your production planning. So adoption of digital is actually going to optimize or make your energy more efficient, and that's where the energy management come in. So the transition is from energy monitoring to energy management, which is integrated with your production planning as well as your maintenance plan. Is there any flip side of digitalization in this sector? If it is not well planned, like I said, cybersecurity is one. So you need to really re-architect your IT and the digital landscape in such a way that your production processes are secure, your organization is secure. Plus, you need to have a vision, and you cannot adopt any digital technology without a sight of future. Technology is changing every 35 to 40 days, so you really need to be updated, and the kind of architecture or the kind of vision that you need to have has to be flexible and agile in terms of the technology development as well as in terms of your production demand. So yes, you need to really think through as to what your future will look like in 5 years, and you will have to plan accordingly into the adoption of technology.
And just to add, I think digitalization cannot be only in the domain of a CIO or a CTO. I think there has to be a very senior level sponsorship. It's a business need. It drives business success, so it has to be elevated, but however well thought about. And also change management is critically important. The adoption, the awareness, the adoption. I think there is a lot of anxiety that might creep in the talent pool the organization may have as to what it means for me. Where do I stand post this digitalization? Am I going to be relevant anymore going forward? So all these questions are critical, and they need to be addressed upfront with a lot of education, sensitization, reskilling, redeployment, and etc., which will be immensely beneficial for the organization. But they cannot be sidestepped, and they need to be well thought about.
There is a question on information security risk. Will it be handled as connected plant and devices, as a risk of technology being exposed to the world? Yeah, so that's opening up new signs of cybersecurity when you have more and more assets, more and more sensors, more and more processes connected to the world and having an equal chance of getting exposed to the world. There is a new science that is coming to design the entire cybersecurity, and the learning is from what we have been adopting in the IT systems, but it drills down much more further because right now we are dealing with digital systems. it actually, I mean, the ground rules are basically the same as in IT system, where a device network has to be independent of the plant network, needs to be independent of the business network in a virtual world. You can run the whole thing on the same network, but when you actually isolate them, you really need to look at those security aspects, how you connect devices at various levels to your business system. So that's a science of its own, and there are guidelines being published. There are organizations that's working towards it.
So in other words, I mean, the exposure to cyber risk would increase potentially, but there are ways to manage it. And science is evolving.
Yes. How will digital improve asset productivity in mining, which is relatively low in India? Taking a simple example of, say, a dumper when it is switched on, basically it's on and it is available, but still idle if it is not loaded and not moving, right? So if I can actually monitor a dumper, whether it's on, whether it's loaded, whether it is running, then I know that it is operational. So it is producing in its own terms, it's working, right? So if I can monitor the status of assets and demarcate between being available, being idle, being broken down, and of course whether it is working to its capacity, that itself gives me the KPIs, or that itself gives me the parameters saying that the asset is working below its capacity. And when you start measuring these parameters that determine the KPI, you start controlling them, you know where the variances are, and that's where the digital is going to help improving the productivity of mining assets.
And also productivity has an element of being available.
Yes.
So I think, and you know that mines are generally are remote places, and some of the equipments which are world class are also sort of imported in many environments. So these twin triggers make it necessary for a better asset, asset availability, predictability of asset availability. So in that sense, digital can be of immense help as well, which in turn will have its positive impact on productivity of the mine.
How far will digitalization affect manpower of labor? Will it affect manpower negatively or positively? Mining and metal industry, if you look at it, and has been earlier also said, is not a very lucrative industry, because they are actually located at far off places from the metros, from the facilities of the hype of life, and that's the challenge. And when you actually get digitally connected, you make it more interesting, and that's what the industry needs to do also. So digitalization will actually help the manpower to be more productive, be more effective. That's one. But then yes, metal and mining industry being the kind of industry it will still not solve the problems of being in remote areas, but at least they will be connected with the world virtually, and they know what's happening around.
Also, interestingly, I suspect more upskilled, assuming that the industry, the organization has skilled up its workforce, it imparts a degree of value addition to the people. It makes them more mobile, in that sense that they because there is a convergence of technologies, and if they have undergo this transitional journey, I think their ability to be mobile, their options are greater. So it will have a more positive impact on the labor as well, as compared to they only know one way of doing things at that particular mine, and hence their options in life are limited. So it also is a potentially career enhancing move for the people to undergo this journey and transition positively. And I think the industry must want that.
So it's time to wrap up this session. Thank you, Mr. Anjani Agrawal, Partner and National Leader, Metals and Mining EY, and Mr. Gangadhar Krishnamurthy, Director, Business Advisory Services EY, for the presentation on the topic, how new generation digital technologies can help boost metals and mining sectors. Unfortunately, we won't be able to take all the questions due to time constraints. If you have any other questions, please send them at editor@etenergyworld.com. It was an engaging and insightful talk and hope all the participants have enjoyed the session. The recording of this webinar will be made available on etenergyworld.com. Thank you everyone for joining us. Goodbye.
Thank you. Thank you.